So good morning, good afternoon, and good evening, ladies and gentlemen, depending on where you are in the world. It's my great pleasure as chairman of the European section of the International Society for Respiratory Protection to introduce you to today's virtual webinar on the basics of respiratory protection standards. So the webinar itself, I'm introducing the society as a whole, so there's just a brief introduction. And we've got three keynote speakers today. Clements from British Standards in the United Kingdom, Dr. Simon Smith who is X-Ray Count 3M, who is going to give us a more global picture of EN versus NIOSH in terms of respiratory filtration standard differences. And then finally, we have Wolfgang Drews, who many people in the respiratory industry know, is going to give us an overview of the new ISO Respiratory Protection Device Standards in terms of aspects to consider. In terms of today's webinar, the presenters will deliver their content and then we will take question and answers at the end in our Ask the Expert question. And then finally, just a few thoughts on future webinars that the Society will be holding for the rest of this year. So just quickly before our webinar starts in earnest, just to introduce for those who aren't aware of the International Society for Respiratory Protection, who we are and what we do. We're a non-profit organisation whose charter is to provide education and information on all aspects of respiratory protection. We have 6 sections. Today, this webinar is produced by the European section, but we also have an Americas section, Australasia, Japan, Korea, and the Society objectives are to enhance health and safety of people that are using respiratory protection devices, to encourage society standards and best practices, again, very topical for today's theme, and also to promote networking, research and evaluation, in short, exchange of information, not just amongst industry, but organized labor, government, manufacturers and other professional organizations, in short, anybody that is involved or interested in respiratory protection. So without further ado, it's my great pleasure to introduce our first speaker. For members of the European section, Graham is very much an honored guest over many years, who's provided some excellent presentations in the past. Graham is the certification manager for PPE at BSI, both in the UK and BSI's new Netherlands function, which I know Graham will add more to. And Graham's going to give an overview of Brexit and the impact it's had on standard product certification in the respiratory protection domain. So with that, Graham, I will pass the floor over to you, sir. You're on mute, Graham.
Okay, we're off mute now. Sorry about that. It's a new phrase we've all learned to hear, isn't it? You're on mute, even in government presentations. So pleased to be here today. Welcome everybody. I'm going to be basically going through what Brexit's about, what's happened. It's a word that didn't exist probably 10 years ago, but once it was coined, it stuck with us. So, and it has some impact on standards, on regulatory side of things, but not so much on the individual products apart from marking. So we'll have a look through, and there are some idiosyncrasies, as one would expect in any negotiated agreement, and we'll figure out what's happened and where we're going. Right, if I can get there we go, page down to work. Okay, so what we're going to look at today, we're going to just have a brief overrun of Brexit, what it was and what the timetable was. And then we're going to look at the conformity assessment bodies, which have changed to some degree, but we'll look at that. And the impact on the UK regulatory landscape, the UKCA Mark, which is the UK version, if you like, of the CE Mark, and the impacts that's had on PPE and in particular RPE. So Brexit, as I say, it's a fairly new word for us. It's been coined as a result of Britain and exit from the EU, and the whole process started a long while ago. We had a referendum in 2016. It's just over 5 years ago. So where have those 5 years gone? And it triggered Article 50, which was a 2-year transition to come away from Brexit. We extended that Article 50 because we needed more time and lots of stuff was happening, and including elections and machinations of our English Parliament or British Parliament. So it was extended again. And finally, there was a government bill that actually approved the process of Brexit. And then it got down to the negotiations to actually come to the terms of an agreement between the UK and the EU. So on the 31st of January 2020, we finally got to the point where we closed that agreement, and then there was a year's transition period, which took us up to the end of last year, the 31st of December. So after the end of last year, that's it, clean break. Brexit's done. We're no longer part of the EU, but we do obviously have agreements, trade agreements, and various border agreements with the EU that have kind of come in over the years as with the UK as part of the EU, and we've had to somehow develop our own legislation that actually mirrors what we had before, because the European legislation obviously doesn't apply anymore. So a quick geography lesson, and many people get confused about what the various parts of Britain, the UK, the British Isles are. So we're going to have a quick look at that. So the British Isles is actually an archipelago off the northwest of Europe that includes 2 main large islands. One is called Ireland and one is called Great Britain. So they're the 2 parts that make up the archipelago of the British Isles. There are, of course, some outlying areas such as the Channel Islands, but they're a completely different ballgame. So within that British Isles, Ireland itself is an island, and that's where a lot of people get confused. But that island is divided into 2 administrations, which is the Republic of Ireland, which is an independent nation, ERA, and Northern Ireland, which is part of the United Kingdom of Great Britain, Scotland, Wales, and Northern Ireland. So we have 4 countries within the United Kingdom. So I hope that kind of explains how it all fits together, because there's geographical terms and there's also political terms. So the 2 political bodies, if you like, are the Republic of Ireland, which is a nation, and the United Kingdom of Great Britain and Northern Ireland, which includes Wales and Scotland, which is another nation. So I hope that helps. Northern Ireland presented us with a problem. It has an open border with the Republic of Ireland, but it has a sea border with the rest of the UK. So there was the Northern Ireland Protocol, which came through as a way of dealing with that problem, because they didn't want to put a hard border in place between ERA and Northern Ireland. So manufacturers in Northern Ireland still have unfettered access with the Republic of Ireland, and theoretically the rest of the UK, although we're having issues, I think, in actually agreeing how unfettered that access is across the Irish Sea to the rest of the UK at the moment, but hopefully we can get that resolved. So importing goods into Northern Ireland presents a particular problem. So companies bringing goods into Northern Ireland from the island of Great Britain, in other words, the rest of the UK, are in fact importers from the UK. And they're also importers from the EU. So it changes some of the relationships of what people do, whether they're distributor, whether they're manufacturer, whether they're importer, or whether they're some or all of those terms, which does mean that there's additional checks in some cases that have to be met. Goods from the EU, companies will be distributors. So they're actually allowing distributors from the EU in Northern Ireland, so they won't actually be importing as far as PPE goes. They'll be distributing. So they don't need to meet the importer requirements, which is a little bit confusing. So we've got an example. If goods come from the EU into Northern Ireland, then the Northern Ireland business is a distributor. If goods are supplied onto GB, the Northern Ireland business becomes a UK importer. So there's a kind of change of definition depending on what you do with it once you get it in your hands in Northern Ireland. But what you can't do is you can't route goods through Northern Ireland to avoid the UKCA regulations enforced in the UK. So you can't put CE Mark product into Northern Ireland and then that CE Mark product go into the UK once the cut-off date has happened for CE Mark goods. So CE marking is applied to products in the UK since the 1990s. So we left on the 31st of January 2020. The transition period ends on the 31st December 2020. And UKCA marking came into force on the 1st of January this year. Now, we are in the transition period, which will be recognised until the end of 2021, or in the case of medical devices, till the end of 2022. So from the 1st of January 2022, only products with UKCA marking will be accepted. That's the plan. There's a lot of work to do between now and the end of the year, surely. So in summary, we left the UK on the 31st of January. The agreed transition period ended at 31st December 2020. Northern Ireland has special provisions, which are confusing to everybody. The role of distributors and importers may change, and that applies to anywhere in the UK and Northern Ireland. And there are transition deadlines. So, conformity assessment bodies. So currently, for the EU directives and regulations, you CE mark it and you go through a conformity assessment body in Europe. And under UK regulations, you'll apply the UKCA mark and go through a UK conformity body. So the conformity body in Europe is a notified body. So a very, very distinct terminology. And they perform the product inspections, factory quality inspections, and in some cases the testing directly to get your CE mark. In the UK, you'll have an approved body. And so it's actually the same process, but just done by an approved body and not a notified body. And BSI is an approved body, and in fact a notified body as well. So we've got the EU directives and regulations for the EU 27 for market access, put the CE on, and BSI is a notified body in Europe and other organisations as well. I'll just give BSI as an example, but other notified bodies are available. But there are a number of us where we have an international presence, so it's an international company, and within that international company they have a European notified body. In this case, BSI is 2797, and because they were also a UK notified body, they've moved to being a UK approved body. So that means they can actually apply the CE mark and the UKCA mark, or authorise you to apply both marks through a product assessment, which can be combined. So the requirements for conformity. So what we did, we looked at all the EU directives and regulations and thought, actually, they're pretty good. We put a lot of work into those. There's nothing wrong with those regulations and directives. We're not picking a fight with Europe. We're just looking at the best legislation that's available. So what we'll do is we'll mirror those legislations in the UK under what was generally known as the Great Repeal Act. And what that did was basically said, in the UK, this European regulation will still apply, or this European directive will still apply. So in that way, it kept things on an even keel for the moment. So all of the regulations, we'll look at the PPE regulation, which is towards the bottom there, becomes in UK regulations, regulation 2016/425, so the same document on personal protective equipment as brought into UK law and amended. Okay, so what they've done is they've made some amendments to how the terminology is used, just to reflect the fact that there's an approved body involved, there's the UKCA mark involved, but basically it's just a cut and paste job. So it's the same regulation. So in the EU, obviously, all of the notified bodies that that you go to for conformity assessment for EU directives and regulations, PPE's on the left there, and you can look those up in the NANDO database, and there's a link to it there when you get the presentation afterwards. And so there's conformity bodies by legislation, directive regulations, countries, specific annexes and product type, which is their scope. So you can actually look in the NANDO database and pick on any of those search characteristics to find out who the notified bodies are. So we had to set something up in the UK to mirror that. So the UK regulations, which are mirrored, and we've got PPE in there, it's a mirrored regulation. We've got the UKCA database, and there's a link to it there when you get the presentation afterwards. And that is effectively the same. So we've got the conformity assessment bodies, body type is an approved body. We've got the locations and we've got the legislation, and there's a few other search characteristics. So you can actually find which UK assessment bodies are available for your product through that UKCA database. So it's just a UK version of NANDO. So in summary, all UK notified bodies became UK approved bodies from the 1st of January 2021. So this was an easy way of doing things. All those UK notified bodies that hadn't registered with a competent authority in Europe and became a European notified body, then became UK approved bodies, regardless of whether they'd taken any action to become a notified body in Europe. So all those that, say, in the case of BSI, we had UK 0086 was our identifier as a UK notified body, and that moved to being UKCA 0086. So the numbers were kept the same to avoid confusion. So a very simple transfer from one legislation to the other. So for the EU, we have notified bodies, and for the UK, we have approved bodies, just a change in name, but effectively the same type of organisation. Notified bodies are listed on NANDO, and approved bodies are listed on the UK MCAB. Existing UK legislation and scopes have been mirrored for approved bodies, so we're still working to the same rules. And former UK notified bodies may have an EU notified body. So this is where we've seen the writing on the wall, and we've got one of our offices in Europe to apply for notified body status. In many cases, like myself, I work from home, but I'm employed by both the UK and the Netherlands, so I can do work on either EU notified body work or UK notified body work. So it keeps things simple, and that's the nature of business nowadays. We're all very global. So the impact on the regulatory landscape. On the 1st of January 2021, the UK and the EU requirements were largely identical from a technical perspective. So that's whether they're marked UKCA, whether they're marked CE, whether they're marked both, whether they're marked UKNI. Essentially, the technical requirements are identical. Most technical rules are contained within standards, not regulations. And this is a key point. The technical specification is what applies to the product. The regulations just put it in a bigger context of conformity approval. So it's the standard which you test against, if you like. So, and the UK has been a very, very active body in standardization. From the very first BS standard back in 1901, I think it was. We've had standards in some form. We've had a product certification in some form long before we had the EU. So it's something that we've been involved in. We're a founder member of ISO. We're part of CEN, part of CENELEC. Remember that CEN and CENELEC are not EU Commission bodies. They are independent bodies. So we still remain a full member of CEN and CENELEC. And we're committed to using those standards. And we're going to continue to use European standards unless one doesn't exist. And we have issues within respiratory protective equipment for CBRN use. We use a BS standard because there is no EN standard available. But largely, the UK adopts ISOs in the same way that Europe has adopted ISOs. And in fact, often the UK adopts an ISO before Europe adopts the ISO. So we see a lot of BS ISOs rather than BSEN ISOs. So we're going to carry on that route. We're into standardization. We're a major part of it, and we're not going to change that. So divergence will be small in the short term. Typically, if we look at an energy label, spot the difference. One's UKCA and one is CE. And really, there's no difference. We've just adopted the same approach. And that's a very sort of illustrative way of saying, well, business as usual. So the role of standards in UKCA marking, we recognise the importance of standards in exactly the same way as Europe. And we use compliance with appropriate standards to give presumption of conformity under most regulations. So compliance with appropriate standards may be mandatory for some regulations, such as construction products. Other regulations are treated slightly differently. It's the harmonised standards are there, but you don't necessarily have to follow the harmonised standard if there are other appropriate routes. But the appropriate standards in the UK are called designated standards. So in the EU, we've got harmonised standards. In the UK, we've got designated standards. And they're nearly identical to the EU list that you can get off the European website. But there are small divergences, and you can probably expect some other divergences in the future. They will be EN standards normally, but they could be ISO, IEC, or British standards, BS. So there's an option for us to develop our own standards. It will only happen in cases where Europe is not conducting work on developing a standard, or ISO is not conducting work on developing a standard. So it'll only be, in some cases, a temporary measure or for a very particular product or use. And you can get to those standards on the web, and they're all available free. There's a download, much in the same way as there is from the European website. So what might happen over time? So we've got the possible divergence. Because the UK and the EU remain free to amend their own regulations or introduce new regulations to suit their own needs. So they may or may not harmonise standards for those, or designate standards for those. So I think we've got to accept there may be some divergence in the future, but the beauty at the moment with the introduction of UKCA is it's almost exactly mirrored. So there's not very little sort of to actually trouble anybody, I think, in terms of actually moving over to UKCA, dual marking to UKCA, depending on how your business works. So in summary, the UK will continue to adopt EN and ISO standards. We're absolutely committed to that. EU legislation will largely remain mirrored in the UK. And if we get any divergence, it will be something that we are happy to sort of notify people of. As soon as we know about it, we'll let our customers know about it, so that you can then start to take actions. The designated standards have been listed. The technical requirements are the same. If the standards are the same, the technical requirements are the same, but that may diverge over time. So we get to the actual part where you've got to mark your products now, the UKCA Mark. So it's available on the internet. So CE, affixing the CE mark to all products declares compliance with all relevant EU regulations, which is very sort of appropriate to respiratory protective equipment where you've got powered air systems, because you've obviously got things like EMC and LVD as well, and may well apply to the power unit. And UKCA is virtually the same rule. Affixing the UKCA mark to a product declares compliance with all relevant UK regulations. So nothing really changes in concept there. So the deadlines for the majority of products, not including medical devices, UKCA marking, you could have applied from the 1st of January 2021, and we've certainly had the early takers through, but obviously a lot of people have got to think about when they do it, why they do it, how they do it, what products they do it with. So it's not been universal. So we're still in a stage now, I think, where the largest players in the market are actively undertaking this process, but some of the smaller players are just kind of thinking about whether they pay additional money to have the UKCA mark, whether they concentrate on Europe, whether they concentrate just in the UK. So there's various scenarios that make people think about what they're doing now. But we do need that UKCA mark in place on the 1st of January 2022, which is the ruling at the moment. Whether there's any easement on that, if we get to the end of the year and it proves impossible for everybody to achieve it, then we don't know. But at the moment, they're the rules, and they're the rules we have to commit to. So you will need the UKCA on your product to place it on the market after the 1st of January 2022. And of course, the same rules apply in terms of what is placing on the market. We're adopting a regulation, so we're adopting the interpretations of that regulation. So there are obviously things will be able to be sold to an end customer after the 1st of January 2022 without the UKCA if they were placed on the market before the 1st of January 2022. So that's going to cause the same confusions that we had with the competent authorities and the market surveillance authorities when the regulation came into force, where they were saying this can't comply because it's to the directive, when in fact it was placed on the market before the cut-off date. So there are potential challenges from the market surveillance authorities or the competent authorities or even the customs authorities. So we'll see how that pans out, really. We'll probably have, as I say, we'll have the same teething troubles probably that the regulation had in Europe. Medical devices, you've got that extra year, but basically the same situation. I don't know why medical devices got the extra year. I think PPE in some ways is just as complex as medical devices. And in some cases that if we'd have had an extra year in PPE, I think it would have been a very good idea. I don't make the rules, I follow them, unfortunately. So who's UKCA marking for? Well, of course, it's for everything that had a CE mark. Pretty well all of those regulations and directives have been mirrored into UK law. So it's anybody and everybody. So, we put a mask in there to highlight that. There's fire extinguishers, there's all sorts. But yeah, so if it had a CE mark, it's going to need a UKCA mark. So the UKCA mark, very imaginative. UKCA, no pretty pictures, no pictures of the British flag, just a very simple UKCA, UK conformity assessment. Very simple. There we go, UK conformity assessed. So it's slightly larger than the CE mark. Obviously, there's a minimum of 5 millimeters on the letters. So we do have issues of actually people managing to fit it on their labels, particularly if they're already got the CE mark. So that in itself presents issues. However, there is the same pragmatic approach where if it can't be on the product itself, then it can be on the user instructions or on the packaging. So we've got the same options there where it makes no sense to try and put it on the product, or you physically can't get it on the product. So it can be affixed from 1st of January, and there's a few UKCA marks starting to appear. It must be affixed before the 1st of January 2022. Operates in the same manner as CE marking, as we've seen. For regulations where there is no approved body, for example, we talked about EMC earlier, we've got ROHS, we've got toys, some simple construction products, some simple machinery and small pressure equipment and electrical equipment. So where it was self-declaration before, it's still self-declaration now. Where we've got an approved body that's required, for example, in a category 3 product, then you'd expect to see the number of that approved body next to the UKCA, as is 0086, but other numbers are available. And that applies to personal protective equipment. And it says UK approved body number must be affixed alongside the UKCA mark. Really, it's very similar to the European in the sense that it needs to be adjacent to, so usually to the right or underneath is acceptable. It's a sufficient size that it can be read as well. So we can combine our markings, so you can have both CE mark and the UKCA mark. There's an example. So that will be a product that BSI had done the assessment for CE. through our notified body in the Netherlands, and had also done the assessment to UKCA through our approved body in the UK. And there we go, notified body in the Netherlands and UK approved body number. So the key differences for now, we've got the EU directives and regulations have gone to UK regulations with the UKCA Mark. The manufacturer must draw up a declaration of EU declaration. Try that again. Must draw up an EU declaration of conformity for their product under the CE Mark rules. And in the same way, the manufacturer must draw up a UK declaration of conformity for their product under UKCA rules. They can be combined on the same document, but we're recommending it's much cleaner if there are two separate documents, because it then can't be confused. So that's just a note from us, really. But you can do it whichever way you like, but we think it's cleaner to have two separate documents. UKNI, we get back to this one. If I didn't confuse you the first time, I can confuse you now. So the UKNI mark. So this is available for products that are sold in Northern Ireland. The protocol's now in force. Goods placed on the market in Northern Ireland will need to meet relevant EU rules. Now, the fact, obviously, that the EU rules and the UK rules are effectively identical means that it does give people the option to do more than one thing at the same time. However, CE marking will be accompanied by UK NI marking when assessed by a UK approved body. So what that means is you could have your CE marking assessed by a European notified body and then have your UK NI assessed by a UK approved body, but both marks would have to appear. So to sell it in Northern Ireland, you have to have both marks. The UK NI is never applied on its own. It has to have the relevant EU conformity as well. So you will only see CE and UK NI combined. You don't need to see CE, UKNI and UKCA combined, because if you have CE and UKCA combined, then you'll meet the EU rules for Northern Ireland and you'll meet any UK rules. So the UKCA alone can't go into Northern Ireland either. So in brief, if your product supplied in Northern Ireland must comply with the EU regulations. So if a notified body isn't needed, it's voluntary self-declaration. It's not voluntary, sorry, it's self-declaration for the CE mark. If it's an EU 27 notified body, it will be the CE plus the number. If it's a UK notified body, it could be the CE UKNI with the UK notified body number. Yeah, it could just be CE and UKCA, and it will be valid for Northern Ireland. So it's a bit, yeah. There are different ways of doing it, but you need to show that you've met the European regulations to place it on the market in Northern Ireland. So in summary, we've got the UKCA Mark developed to provide market access to Great Britain, which is the largest island containing Scotland, Wales and England. Organisations that use a non-UK notified body could lose access to that market. Compliance in GB is demonstrated via the UKCA Mark. The UKCA marking alone will not be valid for the Northern Ireland market. Compliance in Northern Ireland is demonstrated by a CE Mark or the CE Mark or the CE and UKNI Mark if you use the UK notified and approved body. Bit of a mouthful. So if you use a body that can offer both, then they can put both those marks on for you. Northern Ireland businesses can place qualifying products on the whole UK market using CE Mark or CE UKNI Mark. Confused? Yeah, that's what came out of the government. We're not quite sure about that. We've asked for interpretation because that's suggesting that they can carry on putting the products on the UK market with just CE Mark after the end of this year, which isn't how we understand the UKCA Mark working. So there are still challenges of interpretation, I have to say, and that I guess will come out over time. So the impact on PPE generally and on RPE, which is included in the wonderful world of PPE. The modules stay the same. So the activities are the same. So all respiratory falls under category 3 complex PPE, which will require a module C2 and a module D under the PPE regulation. And that's regardless of whether it's CE or UKCA. UKCA has just adopted the regulation, so the modules are exactly the same. Now, you can't have a UKCA module B and a CE module D. You have to have a UKCA module D or module C2 as well as the module B. Now, obviously, if you get that with a body that can offer both CE and UKCA, then those audits can be combined. So rather than doing audits for UKCA and CE separately, you can actually, the organisation can actually combine them and use that evidence to support both marks. So a case study for UKCA marking for PPE, Cat 3, technical documentation, EU type examination mod B, or UKCA type examination mod B for UKCA. And then you've got your module C2 or module D as a choice. And you've got your UKCA declaration of conformity. So the process is exactly the same. You just strike out the word EU and put the word UKCA in. So this is where it gets a little confusing. So if we've got a mask, we apply for UKCA. Now, if it's a brand new product that you want UKCA for, and there is no existing CE certificate, then bodies like BSI, which are international and can offer both, could offer you just UKCA if you just want it for the UK market, or could offer you UKCA plus CE if you wanted to cover both UK and Europe, or obviously the UK and IMARC as well. If it has an existing CE certificate, what we can do is we can mirror that certificate. So in other words, we issue a UKCA certificate that mirrors your CE certificate. Now, if say we're notified body 2797, if you came to us and we already had a certificate for you, we can just mirror that certificate straight away. If it's from another notified body, we obviously won't have the technical documentation. So we need to look at the technical documentation, and then we can mirror that certificate from another notified body as a UK approved body. So depending on where your certificate is now and where you go for your UKCA will depend on the amount of work you've got to do to actually place that product on the market with the UKCA marking under the regulations. So even if we just mirror an existing CE certificate, so I'll just talk about BSI for a minute. If we've got a customer, they've got an existing CE certificate, we mirror that to a UKCA, we still need to see the marking, the user instructions, and the declaration of conformity, because they all need to reference the CE marking requirements in terms of including the details of notified body, the CE mark, and the UKCA approved body, the UKCA mark, and of course the declaration of conformity needs to refer to UKCA and to the regulation brought into UK law and amended. So there's still work to be done, but it is a very simple way of mirroring it. We wouldn't look at the whole technical file, we just look at those three things. If it comes from another notified body and you want us to mirror it into UKCA, we obviously, as I say, we don't have that information, so we need to look at that information. Now, it's not just BSI, we have other bodies out there who can do both. The problem is that there is some divergence between the information that notified bodies request from the manufacturers to meet the requirements of the technical documentation within the regulation. So if you go to another body to mirror your product into UKCA, it may be that they ask for more information than you originally supplied in your technical file. So that's one thing to think about. If your technical files are nice and comprehensive, nice and ordered, then it will be a relatively painless process. If your technical files are somewhat slim and somewhat scattered, then it may be a longer process. So it's good to have good technical files is the simple sort of rule there. So moving forward, we've got BSI UK 0086, BSI Netherlands 2797. This is also true for organisations such as InSpec, and then there are others out there as well. SGS is another good example where they can offer both a UK approved body number and a European notified body number, and so you can get a package put together. So if you've got somebody, if you're with SGS and you want to do both, approach them and ask about a package deal. So it makes sense, and it helps get things through quicker when we've got a lot of demand. And the earlier you can do it, the better, because demand is high at the moment, and we're absolutely sure that as we approach the end of the year, that demand will get higher. And there's only so much capacity. There are European notified bodies that are applying to become UK approved bodies, such as TUV. So there will be options to go to your local notified body if they've applied to be a UK approved body as well. So there's still a lot of options out there, but obviously I'm just sort of telling you how we're doing it, and we're hoping that other people take the same pragmatic approach. Changes to technical documentation. Obviously the marking is different, as we've said. The user information need references to UKCA and approved body. The UK authorised representative needs to be shown on the Declaration of Conformity. The relevant UK legislation should be listed on the Declaration of Conformity, which is basically the EU regulation as brought into UK law and amended. That phrase is sufficient to actually cover the relevant legislation. The standard itself will be the same. The majority of European notified bodies just put the EN number. They don't put the country prefix on their certificates. So we've avoided that deliberately to avoid confusion between different countries. But obviously, if you're referring to the legislation and the designated standard under the UKCA Mark, then you can either refer to the EN directly, or you could refer to BSEN, which is the UK prefix for EN standards that have been adopted by the UK. And of course, the approved body needs to be listed on the Declaration of Conformity as well. So there are a number of changes, and we've got that minimum height of 5 millimeters in the same way that you have it on the CE Mark. So if you were with notified body 0086, there's no extra testing, no extra surveillance visit, and we can move straight to a UKCA certificate. If you were with BSI under notified body 2797, which is European, again, we wouldn't add any extra tests, and we wouldn't add any extra surveillance visits, and we'd mirror your UKCA certificate just with those changes that need to be made. So if you come from another notified body, so you've got another notified body, so you've got a CE from another notified body, and you come to BSI, we may perform extra tests. Now that's that point really is where if you have a certificate that is to an old standard and the designated standard is to a newer version of that standard, then clearly we have to issue that certificate that uses the current designated standard. So in that sense, there may be a test. But saying that, if you got to the end of that certificate, say it was issued in 2018, so it would end in 2023, so your regulation certificate, you'll be in the same boat. So at some stage, you're going to have to add additional testing. We'd obviously try to minimize that. So just with the parts that had changed in terms of the standard, the tests that had changed. But then potentially could be some extra testing, and then we'd issue a new UKCA certificate. If you transfer in, so rather than just get BSI to issue a new UKCA certificate based on your old CE certificate, you actually move your CE certificate to BSI, then again, we may perform extra testing. We do need to do that technical review, and we may have to do an initial visit to the factory and then we could issue the new UKCA certificate together with a new CE certificate as you've transferred to BSI. And I'm using BSI as an example here. As I say, other notified bodies with this dual approach are available. So if you're a non-BSI client, you've got a product that's self-declaration, so say category 1 PPE. You've based it on CE technical documents, and you've got a declaration of conformity even for a Cat 1 product. You can prepare those technical documents and your declaration of conformity, and you could fulfill UKCA requirements. So you wouldn't need a certificate. You wouldn't need a UKCA type examination certificate. But what we have found is that in some cases, some countries where the regulation doesn't exist, they do actually look for some kind of certification. And what we do is, if we've got the testing information, we offer a verification certificate to say that we've verified that testing has taken place, and we reference the report and what testing had taken place. So that's another type of certificate that may benefit people on some occasions. And most conformity assessment bodies offer some variant on a verification certificate. So designated RPE, there are 2 annexes in the designated standards, much as similar to the harmonised standard list. So Annex 1 gives clear variants. I think the designated standard list is slightly clearer than the harmonised standard list, and it gives clear variants of currently designated standards. In RPE, we're looking at it actually gives the option of EN 9431 2015 and the amended version, so you can use either version currently, and it actually expressly says that. And indeed, it expressly includes 14594 2005 or 14594 2018. So very clearly those standards are included at the moment. That actually is quite useful to us in terms of transferring certificates to UKCA certificates or mirroring certificates to UKCA certificates. And these designated standards give presumption of conformity. So Annex 2 gives clear dates when presumption of conformity is removed as well. So standards where the presumption of conformity removed in RPE at the moment, for example, EN 9431 2015, you won't be able to use it for presumption of conformity beyond 19th of November 21. So you haven't got very long left. And there are significant changes between those 2 standards. And it appears to be clothing, but it's actually a breathing suit. So it is RPE in clothing form, should we say. And 14594, similarly, the 2005 version will also lose its presumption of conformity on the 19th of November 21 as a designated standard. So a very similar approach to Europe, but just a little clearer. And of course, as I said, that may be important for mirroring. So if you need to mirror and you've got a situation with any of these standards where you don't have compliance with the latest standard demonstrated through testing, then you may need to act quite quickly. Well, that's the end from me. And you've got my name there, and you've also got my colleague, Amy. And we're happy to answer any questions on UKCA issues further down the line if you have them. And we're quite happy, obviously, for you to approach BSI to carry out that process for you. But there's a lot happening. There's a deadline, and people always leave it till late. Don't leave it till the last minute. Talk to us now. Okay, that's all from me. Thank you very much.
So thank you for that presentation, Graham. It's wonderful. Yeah, definitely keep in mind notified versus approved bodies in my head moving forward. That could be a potential banana skin, but no, that was excellent. And I really enjoyed the discussion around what exactly the United Kingdom of Great Britain and Northern Ireland exactly is. So again, that was very educational. So thank you very much for that. Just one quick question in the chat, which we'll answer now, if that's okay. From Felipe, which governmental UK institution will be in charge to approve UKCA labs?
There aren't any UKCA labs. There are only conformity assessment bodies. So we've got the conformity assessment bodies who will want testing from various laboratories. Those laboratories we'll be looking for will be accredited laboratories. Now, they won't have to be UK laboratories, but they do have to be accredited by an ILAC organisation. So in the UK, that will be UKAS, and obviously you've got trying to think of DAX, is it, in Germany? So you've got a number of ILAC signatories who approve the body's COFRAC, I think it is in France is one.
Okay.
So
fantastic. Yeah. Thank you, Felipe. I hope that answers your question. In the interest of time, I'm just going to move on quickly. So just moving my screen back on. It's great pleasure for our next presentation, which moves on a slightly different field from Graham's talk. Graham's talk was very specific about kind of UK and the changes that are coming from UKCA versus EN. Now we're kind of opening the panacea to include Dr. Simon Smith, who is my former colleague at 3M, and Simon is also a convener of working group at ISO level, so he's very, very appropriate to talk on the next topic, which is EN versus NIOSH filtration standard differences. Just a bit of background, if my screen's frozen, on Simon. He's actually retired from working now, but in his second career, he is now doing an awful lot of standards development work, especially with Canada Standards Council, and he's been involved in respiratory protection for many, many years. So with Simon, it is my great pleasure to offer the floor to you to give your presentation.
Thank you very much. And thank you, Graham, for an excellent presentation. I'm just going to share the screen. Hope that works. And with apologies, I will not show video of myself. I hope that's a relief to everybody. It's just bandwidth where I live is a bit limited, so it'll save a couple of problems if I just close off video. But thank you very much for the introduction, and thank you again, Graham, for a most enlightening presentation. And yes, for my career, I've been involved in the design of respirator filters primarily for about 30 years, and so become familiar over that time with standards requirements around the world, particularly with operating at a plant that made for worldwide distribution. So it's I guess a good chance to talk about that, bring some experience, and I'm trying to present this from the perspective of, if you are, say, a European company wanting to work into the North American market, what are some of the factors you may encounter in dealing with NIOSH standards, and vice versa. If you're a North American company interested in European sales, what are you going to find that's different in the European system? And then basically dividing the talk into some of the general aspects, some of the issues for negative pressure non-powered filters, and then powered filters and escape devices. Just to mention, this is very much an overview. It's sort of high level. There's so much detail in this that, of course, can't possibly cover it in the time. So please don't take what I'm saying as the standard to follow. Do check the documents. You can play Simon Says with NIOSH. Sometimes it works, but not always. And also to note that we're covering performance standards here, as opposed to those for selection, use, and care of respirators. And there's a different set of standards that address those. So bear in mind, you may not find everything you need to know about using respirators within the standards that cover performance. So thank you. Talk a bit, first of all, just to explain the context around the, I guess, the structure and administrative authorities that govern the creation and the deployment of standards and approvals processes. They are quite different. In Europe, we have a regulation that was updated in 2016, addressing the overall framework, and then a central committee that addresses the creation of European standards. And that covers a wide geographic range, all the European Union countries, and some beyond Europe, recognize European standards too. So it's a wide-ranging standard. There are some other standards bodies in the world outside of NIOSH. There's Australian, there's Korean, there's Chinese and Japanese. But between them, the European standards and NIOSH standards cover a very wide range of use in different countries. With NIOSH, it actually was formed under a 1970 Health and Safety Act in the US, and it's part of the Centers for Disease Control, which itself is part of the Department of Health and Human Services. NIOSH standards are recognized in the US and in Canada, and other parts of the American continent recognize those, and sometimes you find elements of NIOSH standards appearing elsewhere in the world as well. So again, there's two parallel systems here with broad reach. Just to say, thanks Graham for covering part of this, the way the system works in Europe. We have a standards development system where there is a committee formed to develop a particular standard, and that has input from various stakeholders, including manufacturers, users, test labs. There's an update schedule that generally applies. Sometimes that is adjusted. For instance, when ISO standards were being developed, some of the European respirator standards were not updated for some time. And the overall process is that a manufacturer would submit to a notified body to obtain a certification that would draw on the performance and testing standards that were going to be described. Test laboratories may undertake the testing, and all notified bodies may do that themselves. There's an overall audit and accreditation system that makes the whole program consistent, but from that, approved products emerge. And so there's a choice for manufacturers of which notified body they can go to, and then the choice of test laboratories to go to. And so it's a sort of market-driven system. For NIOSH, it's slightly different. I've tried to summarize it sort of in a block diagram, but really NIOSH is a one-stop shop. NIOSH is a body that is involved in many aspects of occupational safety and health. I've mentioned it is actually a very well-respected research organization as well that goes on as a parallel entity to its certification systems. But it sets standards, it conducts the approvals testing, it undertakes all of the review of the quality sampling method documentation that manufacturers have to submit, and it issues the approvals. So it's one body doing what is done by different agencies in Europe. It also conducts manufacturer and product audits, and so overall has a very comprehensive system providing extremely good security of capability of products to the user. And it maintains a certified equipment list. All the products that are approved are listed as a searchable list, which is very useful. If you want, as a user of a product, you have a need, say you want a mercury and organic vapor respirator, you can go and search on this list and find all the manufacturers that have approved products very, very quickly in a few clicks. So that's very handy. And of course, it's interacting with its parent body, the Centers for Disease Control, and particularly during the pandemic, we've seen great adaptation and a huge amount of work put into to improve health and safety during that time, and the information that's provided to the public. So those are the two systems there. As you see, that they're somewhat different, and with their sort of legislative background, have somewhat different origins as well. Just to summarize sort of some of the good features and some of the things that might be not so good about them. With Europe, as I say, we have good input into standards development from multiple stakeholders. And if you are a product manufacturer, you have a choice of how to get a certification done. You have a market choice of where to go to notified bodies. Opposed to NIOSH, where you have the one-stop agency, which is good in a way as well. You have one place to go, and they have a comprehensive program. NIOSH requires pre-submission testing. That is, you can't kind of use NIOSH as a trial body to send stuff, and if it doesn't pass, well, you then try again. You actually have to send data along with the product that you are submitting for approval. And so that is where the sort of third-party laboratories come into the system in North America. As I mentioned, they maintain that list that is very useful. For Europe, unfortunately, they don't have a list of approved products. So you really have to go to each manufacturer's website if you want to try and find a product for a specific aspect. And as we've seen, things like Brexit and updates to regulations may force at times recertification product. It's more a burden on the manufacturer to kind of keep up with that. With NIOSH, some things that we find difficult are the fact that some of the requirements are in legislation, so they're quite hard to change, of course, it's an act of Congress. And some parts of it aren't in legislation, and that can affect strange things like even a test humidity depends on whether, for a gas test of a filter, it depends on whether the gas is mentioned in the original legislation or appears later, which is kind of odd. It's not related to I guess, the occupational environment, but that's how it is. And again, being legislation, updating is a long process. And there are several routes that have been done, some sort of emergency provisions and some regular ones. But overall, it appears, I guess, as a general view, there's probably less public input than in Europe for standards updating. So that's the systems. When it comes to sort of documentation, things are slightly different as well. In Europe, there are multiple standards for different types of respirator, even different components of respirators, as you see listed there. Whereas with NIOSH, we have one basic document, which is this 42 CFR 84 Code of Federal Regulations, the one main document. And then it's been supplemented by letters to manufacturers. CBRN standards are on the web. They came out in the early 2000s and haven't been incorporated into the main document yet. And then there's some guidance on test selection that has been issued in 2018. And I've got, I guess, the person to contact for that is not actually provided generally. So you have all of these standards. So in Europe, if you have the choice, I guess, to, in this case, purchase the standard that you need for your kind of product. In terms of test methods, we've got in Europe again a standard that lists some of the test methods. Some are described within the standard document themselves for the products, and there's one standard now that covers some of the generic test methods that cut across standards. For NIOSH, they actually have a website, the Standard Respirator Testing Procedures, STPs, and you can go and download PDFs of the various test instructions for different gas tests and particle and other kinds of preconditioning tests that NIOSH use. And one thing to note is that because the European standard system has to fund itself, they do actually charge for standards, and so you have to buy them, whereas everything that NIOSH provides is free, so and searchable. So that's just a slight difference there. It does make a difference if you're retired, because it starts to cost a lot for European standards. Okay, so there is this difference in documentation, and again with NIOSH, it's more one-stop. Europe, there used to be a good website where you had a list of all the respirator standards, respiratory protective device standards across the range. I don't know if that exists. I couldn't find it recently in the last couple of years. I'm not sure if that's been reconstituted. Okay, thanks. And just before going any further, just to mention, there's some differences in terminology as well. This kind of catches one out sometimes, because you start using words and get people sort of looking blankly at you when you're talking about things. And the main ones are there. There's a difference in the use of the word filter, which in North America, NIOSH standards only relates to particulate filters. Whereas in Europe, it's generally used for any kind of a gas vapor filter, sorry, a gas vapor or particle filter. The words cartridge and canister in the NIOSH system has specific meanings. In Europe, again, we sort of throw canister around to mean any kind of filter. At least that's what I've been doing. Whereas in North America, cartridge is a specific type of capability, capacity level that has certain limits on it as well. And canister is a different and generally higher capacity level that allows use up to sort of immediately dangerous to life and health concentrations. And the words type and class are used slightly differently as well. In Europe, it's just the kind of contaminant that's removed, whereas in NIOSH it means both type and the type and capacity in those terms. We have in the codes that are used to describe the types of filters, we have letters used in Europe for the main classes, so A, B, E, and K are examples. And in NIOSH there are the simple letter combinations of initials, so OV, SD, CL, and so on. So you get these different ways of describing products that then translate into different markings on filters. So here we have two products that essentially are very close together, but one would be called an A1 canister in Europe, and one would be called an OV cartridge in the NIOSH system. Okay, one other thing to mention is a difference in the concept of certification of systems versus components. Trying to describe it sort of diagrammatically here, we have a case on the left there of system certification where in this case, say a facepiece and a filter are approved together. So company A's products go together, company B's products go together, and you can then have an approved use of a company A face piece with a company A filter, but not a company A face piece with a company B filter. That crossover is not allowed in system approval. Europe, for some of its products, has component approval, where the face pieces are approved separately from the filters. So both can achieve certification, and that does then allow you to cross over. So in the chart here, it kind of shows how these things apply. And in fact, the kind of what the one area where component approval is allowed is in negative pressure face pieces and filters. So in Europe, they are approved separately, and you can interchange. You can buy one manufacturer's face piece, another manufacturer's filter. And that sort of, again, creates an interesting market system. In NIOSH, everything is a system approval. And so that does actually bear in wording when someone talks about a NIOSH approved filter. That's sort of not strictly correct. It's a filter that's part of a system. It's approved with a particular face piece or powered air respirator and so on. Just put system in quotes for filtering face pieces, because of course they're a single component. So they are technically a system. But what this leads to with Europe is the creation of a standardized connector, so that different manufacturers' products can be connected together. And that is described again in its own European standard. And it's this kind of thread, colloquially called the DIN thread, DIN, because it came from standard DIN, German standard 3182, and it was adopted into EN 148 Part 1. And by the way, it's gone into ISO as well. What this also means for North America, where you don't have this a standardized interchange system, is that you tend to have unique connectors for each manufacturer in North America, so that not only is it not sort of allowed under regulation, it's also physically impossible to fit different filters onto different face pieces from disparate manufacturers. Okay. Just one more thing on the labels and colors, color codes, because that again is something that is notably different. In Europe, the different types of filter have different colors assigned to them, so that they can be observed from a distance. You can be sure, say as a supervisor, that your employees are wearing the right kind of filter for the environment they're in at a distance. And of course, as a user of a filter, if you suddenly find you've been sent one with a different color, it's an immediate alert that something isn't right. So there are these color coding systems. In Europe, the main types of a filter have their own colors, and when you have combinations, say you have an organic vapor and an acid gas type of filter, you then have stripes. And so the top picture on the right there shows a very nice range of filters that have, in some cases, the stripes representing the combined capability. In NIOSH, again, there are color codes. Actually, they draw on another standard, American ANSI standard, that defines those, but combinations have their own. So organic vapor is black, acid gas is white, but an organic vapor acid gas filter is in fact a yellow label. And so you kind of have to refer to those uniquely. And NIOSH has a default kind of other gas color, which is olive. One thing I note in both cases, they may describe blue and green and so on, but they don't give any kind of descriptive notation. Is a Munsell or Pantone type notation of the color. So you do sometimes get a range of colors. And so the magenta that's used for particle filter, high efficiency particle filter in North America, for instance, this can be a purple or it can be a pink. They're all sort of permitted, but it's a fairly broad range. Okay then. A few other requirements before we get into more of the details on particle and gas vapor filters. There are requirements for materials and design that are roughly comparable. Durability, not causing problems, irritating the skin, and being usable. Europe has requirements on the mass that can go on a face piece. NIOSH doesn't have that, though it does have a test that obviously would demonstrate the problems caused by an overly heavy filter. And then there are some requirements on the use of filters in multiples. Sometimes you may have 2 filters on a face piece or multiple filters on blower for a PAPA, powered air system. And so Europe has a method where you test airflows and apply a calculation to determine if you need to test filters at full flow or can prorate the flow. NIOSH has a statement that they shall be essentially equal, but doesn't actually quantify what that means. And so that's, again, something really has to be assessed sort of by good practices rather than by having a standard to fall on. And then packaging, I'm trying to interpret what packaging aspects. Europe requires the filters to be packaged because NIOSH has an overall respirator standard, which filters are apart, they actually define packaging for the respirator and a container that must protect the respirator during use rather than just during time up to sale. So those are some of the overall requirements. Just a few details on particle filters. That's going to have to be fairly high level. So there are multiple testing methods, and before testing is done, there are preconditioning criteria that are applied. In some cases, for filtering face pieces, there's actually a simulated use requirement. And then in Europe, we have environmental conditioning followed by a mechanical shock or physical preconditioning, where the product is mounted on a metal tray and bounced, as it were, up and down for over 20 minutes, and so given some mechanical shock. NIOSH has less for particle filters with preconditioning. The only one applies to an N-series filter. That's a non-oil based filter, and that is for environmental preconditioning. There's no mechanical shock preconditioning in the NIOSH system right now. So that's the comparison of those two. So perhaps rather more severe preconditioning in Europe. And then when it comes to the aerosol penetration testing, I'm afraid this is rather a complicated table. I hope the documents will be available afterwards for reference. And some of this has been drawn because it's from some of the graphs in the standards, because it's actually the way they're written. It's hard to get comparable information. And the way the standards are written, say with the challenge concentration, it is possible that NIOSH and Europe filters are tested to the same conditions, because NIOSH indicates a maximum concentration for its aerosol challenge, whereas Europe gives a wide limit there. So overall, one can say that the methods are comparable, but they are in detail not necessarily exactly the same. So in the non-oil aerosol test, both use sodium chloride. They have the preconditioning requirements, potentially similar concentrations, but it can vary, and roughly similar sizing of particles. And there are loading requirements where the penetration is measured after a certain amount of the aerosol has been loaded. In Europe, it's load to a certain level and then wait for 24 hours and then check to make sure there's not been a decrease in the penetration. NIOSH, it's one continuous range of loading up to a certain limit. Flow rates are roughly the same, 95 liters per minute in Europe, 85 for NIOSH. For the oil aerosol test, again, there are slight differences, but again, crossover in the concentration applied, and as far as I can see, a slight difference there in the count median diameter. But NIOSH uses dioxyl phthalate, DOP oil. Europe uses paraffin oil. Slight difference there as well. Sorry, again, because of the time, there's not much time to go into this in much more detail. Airflow resistance is measured at 2 flow rates in Europe and at 1 flow rate for NIOSH, and they'll be doing some interpolation in a minute to sort of show that. When it comes to the requirements, there are 3 levels in both, 80, 94, and 99.95 in Europe, and sodium chloride and paraffin oil is required for all types of filter. But we can designate filters for single use or reusable. Again, that determines that whether that loading test applies. It only applies for reusable. In NIOSH, there are 3 classifications regarding non-oil resistant, and then so partially oil resistant for 1 shift use, or resistant for indefinite use, and both those use DOP. What's happened here, we have the NRMP 95, 99, 100 classifications for NIOSH. These were developed in 1995 when the current standard was issued, and we've seen the market sort of migrate to the N. So you have a lot of N95 products and a lot of P100 products, but very, very little of the others. That's just, again, as technology has advanced, it's allowing high capability products to be developed readily, and then the basic ones. I mentioned for healthcare concerns, there is now a system for a joint approval between NIOSH and the Food and Drug Administration clearance for a surgical respirator, where there are some extra tests applied that normally apply to surgical masks that can now be applied to respirators to have a product that is meeting both the Food and Drug Administration requirements for a surgical mask for use, and then also NIOSH filtration requirements. Again, there's some good papers on that I can share if people have an interest in that. So those are roughly the comparisons for efficiencies and test methods for aerosol penetration. So systems, it's like a ladder, there are different rungs, but overall the ladders have roughly the same height. Coming to airflow resistance on the particle filters, just to say, plotting out those resistances using pascals as a unit here, based on the data in the standards. We see something like this for the 3 levels in Europe of particle filtration, and NIOSH actually has the same airflow resistance, whatever the type of filter. Doing a bit of interpolation so we can compare all the airflows, in this case at 85 liters a minute, how these look for filtering face pieces, inhalation and exhalation resistance. You see it's a sort of ascending scale in Europe, compared with what NIOSH has there. NIOSH allows up to 343 pascals, for instance, for inhalation. One observes in general that there are products on the market that are not anywhere near the NIOSH limit. They're often well below half of it. So although that standard allows product up to that resistance level, often because of market forces, manufacturers are aiming to make products of lower and lower airflow resistance, but these are the limits in the standard. When it comes to filters applied to a face piece, again, NIOSH has one fixed level, whereas in Europe allows extra resistance according to the face piece type as well. So that's the effect on the P1, P2, P3 levels in filtration there. Again, fixed for NIOSH. So again, in this case, some of them go higher than NIOSH. Okay, sorry to leave particles now and move on to gas vapor filters, some examples of different styles here. With gas vapor filters, first of all, we're talking about the service life as the important measure of the capability of the filter. And I borrowed a diagram here from an ISO standard showing a test method to determine, again, the capacity and overall suitability of a gas vapor filter. Generally, the testing is undertaken creating an atmosphere that's containing a certain concentration of the gas fed into the filter, and then measuring the effluent air from the filter. And often the profile that comes out is a sigmoid type curve of concentration over time, and standards define a concentration, so on the vertical axis, that must not be exceeded by that curve for a certain time. And so they set a duration limit. That's pretty much the standard profile of most gas vapor filter tests. Carbon monoxide and the catalytic removal in that case by filter types means there's some different provisions in those cases. Again, sorry, not going to cover those details today. So that this is sort of the basis of the definition of the standards is based on these breakthrough curve profiles. And so we see that. First of all, a list of some of the gases that are covered by these standards. And they are kind of grouped in different ways in the different standards. First of all, you see the types, then the agents. Europe sometimes groups agents together. So to get the class B type filter, for instance, type B, you need meet requirements for 3 gases. And likewise for the low body organic, you have to meet requirement for both those gases, dimethyl ether and isobutane. And so there are sort of multiple requirements per filter type there. For NIOSH, it's all individual. You get an approval for individual gases rather than the groups. And then, as indicated under the NIOSH column, we have the terminology cartridge canister, and they also have one front pack mounted, which is kind of a body mounted filter. And that then is, again, it's split. For some gases, you only have a cartridge or a canister, and for others, you may have all 3 types. I've put it in the codes and colors, in fact, as well. And the indication there with the shading is, in fact, that in some cases, the requirements may be modified from the basic durations that are required for service life. There are some allowances made for certain gases and certain combinations of gases that I'll get to in a minute. Mentioned Europe has one more class, which is for specific name compound. That is, the manufacturer can indicate which chemical they wish to have the product approved for, and there are test conditions for that. With NIOSH, that would generally be by application by the manufacturer as a mechanism, but it sort of sets a more permanent level within NIOSH. A couple of the European filters mandate that there's a particle filter associated with the gas filter for nitrogen oxides and for mercury vapor. NIOSH doesn't. So you sometimes get mercury vapor filters with and without a particle filter. So that's say quite a range. Just to mention one thing on organic vapor test agents, because it seems confusing that we have carbon tetrachloride and cyclohexane used. Carbon tet was used widely internationally up until the mid-1990s, but was banned under international protocol. Some studies were undertaken to find replacement chemicals, and cyclohexane was generally the one accepted across the world as an alternative to carbon tetrachloride. I think Chinese standards still use benzene, but that's how things are. In North America, or at least the US rather, sorry, adopted the protocol slightly differently. That they allowed continued use of existing stocks. NIOSH bought a couple of drums of carbon tetrachloride and continues to use it for testing. And if you're a European manufacturer wanting to get into the NIOSH market, that can cause problems because you cannot legally test with carbon tetrachloride in Europe. And so you would need to use a North American or actually a US-based third-party lab to obtain the pre-submission data that you need. NIOSH has gone to cyclohexane, for instance, in its CBRN standards for organic vapor, but for its main testing still uses carbon tetrachloride. They did identify pentane as an alternative back in the early 90s, but that does have problems when it comes to vapor generation. It's a low-boiling organic, bubbles swarm in feed systems. Unfortunately, the concession made was that you can use alternative chemicals, but for submission purposes, a correlation to carbon tetrachloride must be shown, which effectively means you have to test with carbon tetrachloride. So unfortunately, yes, there's a slight hiccup in submissions for organic vapor stuff into North America with that. Some of the test condition examples, there are tables in the standards laid out. I've just kind of summarized them in similar format here. Again, based around that breakthrough curve criterion, so that the sort of the test concentration at the top there is indicated, and the break concentration and the minimum service lives appear in these tables. Where we go, here the flow rates are slightly different between the two, well, actually very, very different. Half requirement in Europe compared with NIOSH for negative pressure. And so that does lead to differences in capacity. Mention preconditioning as well, because that's kind of very different between the two standards here. In Europe, we have a mechanical stress, a rise and drop that I've described, the filters constrained in a tray. For NIOSH, it is humidification preconditioning, where we have filters allocated to receive different kinds of preconditioning humidities and at different flow rates according to whether it's a negative pressure or powered air filter. So the effect of preconditioning then changes the test flow rate that's used. And in some cases, it changes the humidity that the filter is then tested at. And so sometimes it's 50% up relative humidity across the board. Sometimes it changes according to the preconditioning humidity. And again, for powered air products, the duration requirements are halved based on pre-humidification. It's quite a complicated matrix of requirements that emerge with NIOSH because of the different concessions that are made. Just to mention, when you read preconditioning in some of the NIOSH protocols, they may term it equilibration. In fact, the conditions they set there do not technically equilibrate the filter. They may get close to it, but they don't actually necessarily mean that the filter is fully saturated with moisture at the humidity indicated. And this is not a trivial thing to do, by the way, from long experience. It requires a complex control system to do this humidification properly. So just bear that in mind. Okay, so given all of that complexity, there's one more twist, and this is that certain combinations of gas vapor filters with NIOSH then trigger a change in the required service life. And I'm emphasizing this here because it does actually have significant implications when it comes to designing filters, particularly powered air filters. And in the documents, it actually appears as a footnote in a table, this sort of almost hidden away at the bottom of a table, a couple of tables. I'm involved right now in preparing a Canadian performance standard for respirators. Like, the world needs another performance standard, but there's reasons for that, and maybe we'll talk about that next year. And so I've, as part of that, actually pull out all this information sort of in an explicit table to take a look at how it applies. And basically, it is the case that if you have a filter that is capable of multiple types of gas removal, say organic vapor and acid gas. If it can do that, then the allowance, the service life duration is actually reduced to half for individually for the organic vapor and acid gas results for cartridges for certain gases. Again, for gases that appear in the legislation. So ammonia, your gas life will be halved, but formaldehyde, it won't be. It's just, again, the way the standard has evolved. But you see here a summary table that affects mostly cartridges, some canisters that involve carbon monoxide, and then the front back mounted where it's this historic multi-gas product, the type N filter. So that's again something that I guess has taken some study, but there it is for use by people if it comes to these design issues. Just to sort of summarize the capacity differences, again, doing a crude calculation of concentration times flow rate times required duration. So this isn't actually how filters actually perform, it's what the minimum criteria are for the standard, comparing organic vapor, acid gases, and ammonia, just as examples here for those classes. You see there the blue lines being, or blue bars being Europe, red bars being NIOSH, how the capacity limits are compared. Generally, NIOSH is higher, sometimes not, and you see the sort of jumps in capability. Just technically, there are very few class 3 or front back mounted products used nowadays. Probably Russia is the biggest user of them as a country. You see they're quite popular there, but in Europe, generally there are only class 1 and class 2 products. And again, NIOSH cartridges predominate, canisters occasionally. So that's just again for comparison and information. Yeah, sorry, that's just when the calculation was done. Okay, just to compare airflow resistance of gas vapor filters, again, there's a kind of scale system, and NIOSH fits within what is generally a range within Europe. So it's fitting well for gas vapor only and for the particle filters there. Okay, just to mention powered air, I realize time is moving on, so I don't have a lot of detail on these. For particle filters, they are handled differently. For particle filters in Europe, the overall capability is system related, so that there's actually a inward leakage test that is undertaken on the powered air system in use with an operator. And it is the overall protection that the wearer obtains that's important, rather than the individual capability of the filter. That's how the system, the standard is based. And so there's no minimum flow requirement and no individual filter particle penetration test. It's overall on the overall protection. With NIOSH, we for many years have only had one class of filter that was subject to some fairly sophisticated testing. But in April 2020, there were 2 new classes created, and the PAPF 100N and P actually tend to match roughly the requirements of the negative pressure N and P type 100 filters. So that's potentially opening up the market for products that are smaller, lighter, perhaps cheaper, because the filters do not need to withstand this particularly onerous clogging test I'll mention in a minute. Oddly, the aerosol penetration and subsequent gas testing as well, where it applies there, is measured at a fixed flow rate, no matter what the blower gives as an output. It's the same flow rate is used for testing always, which I guess may be a problem as technology advances. Filtration efficiency requirements are all at the highest level, 99.97% efficiency, and they're tested with the oil aerosol for the HE class, and sodium chloride or oil for the N and P types. Just the clogging test is an interesting one. There are clogging tests both in Europe and North America. And this is where a system, a powered air system, is run inside a dust atmosphere that is specifically controlled for a defined period. And the flow is checked in Europe and must exceed a manufacturer's minimum. And for North America testing, it must exceed, again, the defined minimum flow rates in NIOSH. And so you see in Europe, the style of testing is generally a benchtop mounted system in which the blower system is put. Requirements for the NIOSH test are generally something like a shower cabinet size. It's a much larger test. But it is an unpleasant test. It is being phased out in Europe across the board for all types of filters. So dolomite testing will go away. At the moment, it's continuing in North America for the HE type filters. I'd say it is a system test, and I was keeping off system requirements, but because the performance, the filter is so critical in determining how the blower performs, because it's both the resistance and its ability to withstand clogging then determines how fast the blower fan can operate and what the power draw is. A filter design is quite critical to passing the silica dust test. Just to mention gas vapor, there are changes in Europe. That's class 1, 2, 3, where you normally have testing at 1,000, 5,000 or 10,000 parts per million. That drops. So the net effect of this is you can actually have filters for powered air purifying respirators that are similar in size to negative pressure ones, because this lower concentration is allowed. It does create a bit of confusion sometimes with labeling products as well. The other types of filters like AX don't change any conditions, which does make it very hard to make a powered air AX filter, because simply you're multiplying the airflow. So that beyond that, overall requirements are very similar to what I showed. The testing is at the interactive flow rate of the blower system. So you have to undertake testing to determine that before the gas vapor testing can be undertaken. For NIOSH, they've kind of transported cartridge and canister technology into powered air. A canister only applies to tight fitting systems because they must fail safe. So we have these two capacity classes, and again, testing is at a fixed flow rate. Whatever the blower system can deliver, it's always fixed. 115 liters per minute, that is actually in the old units 4 cubic feet per minute, and tight fitting 170 or 6 cubic feet per minute for loose fitting. And that perhaps has some concerns from technology as we get more advanced systems that can deliver higher and higher airflows. These tests aren't reflecting those airflows. And so you may have situations where it can pass an NIOSH test, but in practice, there may actually be issues with the airflow being so high, you have sort of critical bed depth issues in the filters. Just one last class is escape devices. And there are two standards in Europe, fire escape and mine escape systems. That incorporate specific sets of gases. Again, sorry, not time for details here. In NIOSH, slightly different in that you can choose the gas types for which the intended escape device is for use. And in both cases, mouth bit type designs. So you have, as you see on the diagram on the right there, a piece that is gripped in the mouth with a clip to block the nose can be used with attached to a filter. So I think that's just about everything. Oops, sorry, going backwards. Just some references here to the regulations and standards in different places, and where to find some of those NIOSH sources of information. So thank you very much. Very happy to answer questions, and if people want to get in touch after, I'll try and help if I can as well. Thanks.
So thank you for that, Simon. That was a very comprehensive end-to-end discussion in terms of filtration. Just a couple of quick questions. The first one from Gary Faro. He's asked, could I ask why you believe the N95 is considered the gold standard of disposable in the US and general media coverage during the pandemic, rather than the N100, which has higher efficiency?
Goodness me, yes. I'm sorry to say I have asked people the same question. I'm not sure. I think it's just a media thing that they've picked up on, the fact that compared with items like a surgical mask or cloth respirator, an N95 which fits the face is obviously offering so much better protection. But yes, why gold standard, I don't know, but I see that in Europe, see it in North America, and I can't explain it. I will mention something on that subject though, because I have actually been a peer reviewer for some papers, and there have been some presentations at the ISRP conference in recent years. When you come to comparing overall protection from N95s and N100s, because of the higher airflow resistance of the 100s, any leak paths may actually lead to preferential flow around the filter face interface. And so you may, from some of these studies, end up with overall lower protection from an N100 than you do from an N95. Just as sort of an aside thing, and I don't think that's going to thinking of the people saying gold standard, but it is very odd. Yeah, I would say a P100 or a P3 should be the gold standard, but yeah, it seems that perhaps these things, yeah.
Perhaps okay. Perhaps it's commercial availability. Perhaps that's might be what's driven it. Yeah, as Menno said, maybe N95 is easier, more available, and the breathing resistance is somewhat lower. So yeah. Yes. Yeah. And just the other one is a comment from Menno at Picares. In Europe, clogging dolomite dust test is phased out under EN 14387 and EN 143 filters already, and will most likely for EN standard for PAPR systems as well. And just in the interest on that, so Carl, who is one of the conveners of the ISO committees, which is moving on to our next talk, has kindly sent a link. So for colleagues outside of Europe who aren't necessarily familiar with the EN standards, we will circulate a link to basically the send search function on respiratory standards for anybody that's interested in more information. So, but with that, Simon, just a very big thank you. That was an excellent presentation. I'm just going to share my screen now. If you stop sharing yours, Simon, that will be great.
Okay.
And then hopefully everybody can see my screen. Oh. So it's our final talk of the day. It's a very great honor to introduce back another person back from retirement, so to speak. It's great to introduce Wolfgang Drews, who is a former Draeger safety employee and former chair of the ISO TC94 SC15 committee. And I couldn't think of a better person to talk about ISO standards than Wolfgang. So Wolfgang, over to you, sir.
Yeah, thank you. Thank you, Dave, for giving me the chance to give some information about the ISO. Let me find where it will be. Sorry, I'm not that familiar with this.
Yeah, it's come through. Yep, there we are. That's brilliant.
Thank you. Sorry for the delay. Yeah, first of all, thank you for giving me the chance to give some aspects on the new RPD standard, and I have met a lot of people joining in, and I hope I give some information to that. And I like to switch off my video if you allow me to do so. The first of all is the main aspects of the ISO standardization is the wearer. The wearer is in the focus, and all is about to protect the wearer in the environment, in the hazards, or in the hazards coming up in the environment where the wearer is working. The further issue is that ISO presents always a description of respiratory systems beside one exception, that is what we learned from Simon, as the filter and the respiratory interface, or the face piece in old terms, have been the chance that they can be mixed due to the effect that the threat is specified, and there's a standard on the threat as well given. The RPD has key elements. One key element is that the standards describe the performance and of an RPD, and that is based on human factors in the relation of the wearer orientation. The human has, the study on the human's capability gives a lot of the limits of requirements. So that you always can ask, why is this limit given? And the answer ties into the technical specification of the human factors. The second key is that there will be, or is, one classification for all RPD. That is absolutely new, because so far every standard has its own class or classification. Now it is possible that you can describe performances via the classes. And if you have the same class on a product, you can be sure that the performance is the same. The third issue is that there will be a guidance for the selection, and there will be a procedure to select the adequate and suitable RPD for the wearer to conduct the task in the environment in the working place. So the three gears of this gearbox here tie into each other, and I give some focus how that will be done. First of all, what you learn and has to learn is that there will be no further design names, no names for respiratory devices like N95, as we have learned previously in the presentation. So forget about all the names, but you concentrate on two groups of RPD. And the one is filtering and the other is supplied breathable gas area. Two groups, but one classification. And in the classification, you will have the key elements like the protection levels, like the ventilation rate, like the respiratory interface, the particle and or gas and vapor classes, or respectively for the supplied breathable gas, the capacity of available breathable gas. Those key areas will be covered in the classification I will show later on. A little bit into the flow of documents. We started in the, and if I say we, I'm still in the mode to be part of the SC15 group. Forgive me about that. Retirement is not just switch and switch off and you forget about everything. Terms and definitions very essential to define in the beginning. Then the foundation I spoke already about is the human factors. 8 documents came out of this very intensive study of the capability of humans. Then the performance documents describing the filtering and the supplied breathable gas devices and the application these devices being used in. The classification carries these performance documents, and the test methods, same as the approach in Europe, the EN standards for testing. ISO has 14 test methods. Not all of them are new. They have been taken from existing ones. Some are modified and some are really new. I would not like to go into that details. Very essential is then the selection process, because that ties into the taking the real protection, the right RPD for the use. And that gives me the overview of the structure of the performance documents. You have a general document, it's 17420 part 1, followed by the basics, the filtering RPD 2. Then 3 will be the thread connection between the respiratory interface and the filters. And 4 is the supplied breathable gas. Then there is a big group of special application, and those applications like fire services is part 5, or escape. It's a group on its own. It's a special RPD group is part 6. 7 is then, I call it here, other than 5 and 6, which means it's mining, it's welding, it is the marine, and it is abrasive blasting. So really special areas of application. And the CBRN group has an own as well, tied into filtering and supplied breathable gas, part 8 and part 9. Both are technical specifications, but will come up as ISO standards later during the course of further work. Into the special application, escape is included. It's not an own separate document, and for radionuclear filters, this has been taken into the group of CBRN rather than in the filtering RPD. So the special application fire services has a joint group who creates these documents. That's a group between SC14, Firefighting Ensemble, and SC15, Respiratory Protection. And the special knowledge about the special application fire services has been taken into account, and so that group creates these documents. The first note how to use this standards is that all RPD have to fulfill the general requirement of the part 1. That is not a document that you can take and specify an RPD on that document. It is not for certification purpose valid, because to every further application you need the question answered whether the RPD and where the RPD is used, and that derives the setting of the course, be it in filtering, inhaled gas area, or do you need supplying the breathable gas. So very important, even if you are, let's say, designer in a manufacturing area and you like to design an RPD, you need to know about the answer question on that question. Where is the RPD being used? So the knowledge about the market, the use, it's very important, because that derives your activity in designing the right RPD. Or being in the safety engineer area, you need to ask yourself, what are the environmental issues? What are the hazards? So that you really take the right document in hand to get all the information. The third note is that further application, be it those from the special areas, gives you further document information by further documents. So it's built up like a cascade, more or less. Fourth note is all of the key issue is related to the risk assessment necessary to apply on the working area on and those risk assessment, one method of risk assessment is given in the ISO TC 16975 part 1 and 2, and going through that selection process, based on the risk assessment output, you get then the right RPD class needed for that application. So as an example, I have here taken the SCBA route for the use in the industrial area. You need, as note 1, the part 1, and then the supplied breathable gas. That's it. And you can then ask for certification on this route here. If your special application is in the fire services, there are new further requirements to fulfill. So you need then, based on the part 1 and 4, the special requirements to fulfill out of part 5. That is the cascade that I mentioned earlier. If you like to use then this device in an CBRN application, and you need to get further requirements to fulfill, you have to look in that document, part 9. And all of that will tie into the overall classification scheme. So you can read out of the classification, what is this device capable to fulfill? Another area from the filtering aspects, the assisted filtering RPD, a pepper for the industrial use. You see here the 2 documents to fulfill. If you are in the welding industry, you need then to fulfill part 7, where welding is covered. Same principle, but on the other route of devices. As I mentioned earlier, the human factors is the foundation of the document, of the standards. We have 8 documents: metabolic rates, thermal effects, hearing and speech are some of those. And anthropometrics, I would like to give as an example. That is the study around 3,000 heads being scanned to give the contour of the respiratory interface, or the interface between the human and the respiratory, that is the face, and the most the times the face, because you need to protect your lungs from the environmental threats. Out of these 3,000, 5 head forms have been derived to represent the 5 to 95 percentile of all head forms. And all these scans have been distributed on a graph, which is called principal component analysis, which is this one. And all the blue dots are individual scans, and the outer ellipse is the 95 percentile of the overall wearer, which are, let's say, the adults in the working environments. No children are covered here, but the adults worldwide, including the specific Asian groups, have been taken into account. The inner ellipse seen here, a lot more of these scans are in that area to find, and those ellipse covers 50 percentile. The scans have been taken and summarized to represent the areas. Here, the inner ellipse, we call that face contour M, small or large, or short, wide, and long, narrow. Why do I present this in detail? The reason for that is that this human factor anthropometrics gives you the basic for creating the RPD head forms. And for example, I take the small individual scans. It's an overlay of 5 scans at all. It's not one human being taken as a base here, and that by a process of the CAD design has been laid out to show the head form contour with the mouth opening as a circular tube. You find again the 5 head forms, and all the head forms have the inner trachea simulation by an inner tubing, which is the same for all of the head forms. That is very, very essential to get comparable results tested by individual labs to get the right data, so to reduce the influences by setting up the test methods and test rigs. And that is again the question, why do we have 5 head forms? And it comes to the clear indication so far for test purposes there is one test head only, and we all know that there are various sizes of interfaces available, of mask face pieces, and when testing a small face piece on a big, relatively big head form, it can create some differences. So the head forms is another aspect to consider when you design RPD or when you select an RPD. Why is that? When you design for a specific group of the wearer, as I shown, 5 to 95, that is the overall group. But if you are interested only in the small face size group, you can and you are allowed, the standard gives this route to select specific face head forms for your design. For example, you as a manufacturer, you have to define which area on the market you like to cover. So you define the size of the head form being taken for testing. If you do that, you need to show that this respiratory interface has been used for testing. For an example, you are only interested in a small user group. So you take the, let's call this type of a respiratory interface size special. So it covers in the area of the head form. It is the one, and you have to show that on the circle. If you have, let's say, 3 sizes, you show then which size has been tested on which head form. For example, the first is a small, being tested on 1 and 2. The second is the medium, is tested on the center of the ellipse. You show this ellipse in the document which is delivered with the product, and that gives you the indication by the eye in the circle. Look into your description, and then you find the information there. It's not on the product, it's not on the respiratory interface. It would be too much of an effort to bring all this information on a, for example, a filtering face piece. And large is then the other area. Or if you decide to have one size fits all, you have only one respiratory interface, for sure you have to show the evidence and the verification by testing all of the 5. and the indication in the your information supplied with the product shows you then the ellipse, and all the 5 areas are covered. Performance, the key element, is defined in the capability of the RPD to protect the wearer at the metabolic rate, the wearer demands for the application and task. And here are some of the performance, not all, but 2 of them are very very necessary, informative for the tie into the classification. The total inward leakage is based on the different respiratory interface being created in the group, from mouthpiece only up to the body, totally body coverage, and in between the other well-known respiratory interfaces. No names any further, but letter indication, A to E, and T for tight fitting and L for loose fitting. All of them will be tested in the all of those tight fitting respiratory interfaces will be tested as known in standards of today, and the output of these tests by humans on a treadmill gives then the classes, the PC class 1 to PC class 6. The class 6 is new compared to other classes in other standards. It's a total inward leakage of 0.001. That is a factor of 100,000. The ISO approach is not using the direct factor, but tie into the, let's say, uncertainty between the laboratory testing and the real workplace. And so there are factors included to limit those protection levels into 10,000 instead of the 100,000. And that is then in relation more to what we have seen in other standards. But as known, 10,000 is only known in the CBRN area, a very, let's say, restrictive area where the high potential of the threat is given. So that has been taken as, let's say, a driver to put in the class PC6 for all RPD, if applicable, and if manufacturers or users demands that area. The other very important for the protection of the wearer is the work rate, the ventilation the wearer has during the use of RPD. And ISO has 4 work rate classes introduced with the profile based on different levels of ventilation, on setting of the breathing machine. The high work rate level 4 is on, let's say, ventilation rate of 65 as a continuous ventilation flow, but has peaks of ventilation of 135 liter per minute for 2, but not more than 5 minutes only, because humans are not capable to work that, to breathe that intensively for a longer time. That has been derived out of the studies of human factors. but it can happen. And when you are under stress and have to work very intensively, this peaks will being produced by the humans, and the RPD have to cover that ventilation demands. So that's why these higher flows have been introduced. Beside what we learned from Simon, there are testing on filters on the standard test flow rate, yes. But if it comes to, let's say, demands in the market, then it might be that, for example, as the pepper flow rates we have heard, is only taken on a standard level. But what happens if the demands of the wearer during work has higher levels, and devices will produce that? Are the filters being capable? Here in ISO, even the powered air purifying devices will be tested according to these ventilation rates. And that is relatively new, that this applies as well for the filtering group. That I already mentioned. Coming to the one class, the one classification, that is to show you the protection class, because the capability of the RPD has to protect the wearer at the work rate the wearer demands, the respiratory interface used, and the specific information about filtering and supplied breathable gas, plus those information from the special application shown earlier, as they are here written on. To give you an example for that, I start with the supplied breathable gas, and the specifics after the three key issues is the source has to be mentioned, be it either from a canister, then it will be the S for source and the liter for the gas being or capable to use. It's no longer that a cylinder has, let's say, a liter capacity. It is the liter of the gas being available. Or the other source is when you have an infinitive source of gas flow, not limited to a cylinder, then there is a Y added to the S, and you have this indication. As an example, taken the SCBA earlier, you have a PC5 class, quite relatively high protection. We have work rate 4, a CT is a face piece, tight fitting. The information I leads you to the respiratory interface being tested on which head form, and then the source in liter. In this case, it's 1,500 liter. Or an airline, same three elements of the basic classification. Here it's a hood, a loose fitting, and it is being taken as an SY due to the flow. The example for the classification of filtering RPD is for a half mask with a filter. Same three in the beginning. Here with the BT, that is a half mask tight fitting with the information which head form being used for testing. And here we have a particle size F2 particle class F2, acidic gas class 3, and the lower letter W indicates that this filter has been tested as well to the workflow, the work rate flow of W2. The full phase mass is here another example with a work rate 3, and the filter, it's an acidic gas and basic gas filter class 2 and 1 with the flow according to the work rate 3. There is this exception on the system device, which is if you use the standardized connector, there is another symbol that are the two circles tied into each other, that those being individual tested as a respiratory interface and the filter the cartridge itself. And though with this further requirements, you can then combine the filter A with the respiratory interface B, and you have a full system being fulfilling the overall requirements as if it would be a system device only. From the special application, you get further indications for the classification. For example, the firefighter has the letter code FF, and there are 5 areas for the firefighting service, that is from wildland to structural, and with the indication from 1 to 5, FF1 to FF5. And the specific here is, and not only for special application, it's a general requirement. Whenever you have work rate 3 and higher, you need to be in a positive pressure for the inhalation requirement of the breathable gas, because on the testing on a treadmill for the total inward leakage, there is it's not possible to have the test subjects being treated by this high flow rates to perform over the period of time an RPD delivers the protection. So normally the profile on the treadmill is on the basic of work rate 1 to work rate 2. But when it comes to the higher flows, there is no verification that the protection class is really validated for these higher flows. And that's why there is a so-called safety margin built in, that with those workflows, work rates higher than 3 and 4, that you will have a positive pressure device. We do not call it positive pressure under the ISO terms. It is the inhalation pressure has to be greater than 0, which is basically the same in fact. The example is taken here. Let's say it's the same as above, the SCBA, but here used for the structural firefighting. And so you will get at the end the FF5. And you can see out of this classification scheme the capability of the RPD. And if it would be a CBRN, additionally, the CBRN class will follow. The third key is the selection and as I mentioned earlier, that gives you what you really need in your for the RPD specification. The protection class derived from the hazards in the environment, the work rate you will get by the study of your tasks to fulfill, and the suitability is taken by the specific information you will get from the various physiognomy, from the various face contours and such. All of that is given in the document 6975 part 1 and 2. At the end of this process, you will have then the RPD class, and that with this standard, with this classification scheme you will get out of the this process, you can then ask for the supplier or manufacturer, do you have an RPD with this class? And that's a new approach, and it is not any longer please give me what I have already purchased over the past years. Here you have the chance to look into the detail, and maybe you have overdone the in the past the purpose of the RPD, or the other way, you have not had a good process, a good protection of your wearer, which would be the bad case. And not that this scheme ties into, you ask always for the highest class. If you do that, you can do that for sure, but it might be then you overdo it. As an example, this is only the first chart looking into the details so that the output will give you the class. So that's the end of my aspects. In a summary, the variant orientation is a key aspect. The new designation of RPD is like a new language you have to learn with the elements of the classes, the use of the performance standards, how to select the standards according to what are the really usage of the RPD. Then the RPD, the respiratory, the designation of the respiratory interface, which head form is used for which respiratory interface. It's the first time that the manufacturer has the choice to designate the respiratory interface in the beginning of the testing process. Then the classes for respiratory interface to get the protection, the work rate classes, the classification scheme, and the marking to get all the information you need for the performance of the RPD. And finally, the selection procedure, which really gives you a good guidance to select the right RPD for the best protection of the wearer. Thank you for that. We have almost all the ISO products published, and thank you for your attention.
Thank you for that, Wolfgang. That was an excellent, very in-depth look at kind of the ISO standards. From my perspective, sat on a few of the committees. It is a very kind of step change from the existing legislation and regulations regarding respiratory standards in terms of, as you've eloquently emphasized, it's more of a selection process to make sure that you're getting the best product, the best respiratory protection device for the application that you need. So from my perspective, yes, it's very much, the personal view, it's very much a step in the right direction. So thank you very much for that very comprehensive run through. Just one question, there's one for Simon, but just to keep with Wolfgang for the moment, there's one in the chat box, Wolfgang. So are there ISO approved RPDs already in the market? And are there available laboratories who could test RPDs using ISO standards? Very good question.
Yeah, indeed, it's a very good question. I can give directly the answer. To my knowledge, there is no ISO certified product available in the market. The second question, we have published and delivered the 14 test methods very early in the run of the publication of all the standards. The reason for that is that every test laboratory could have a look into the different test methods, be they different to what they have already, what are the differences, and if there are new areas, what they have to, let's say, invest to get into this position to test an RPD on all of the test methods. And this process was a very slow transition into the test lab. You could not really get the full answer. Yes, we are prepared to test the RPD, because a lot of test labs are, let's say, market driven, and if there is no demand on testing, they would not invest into that direction. So there are only a few which have looked into the future and prepared themselves step by step. But I'm not in the position to tell you that all test labs available being ready for testing. It is a process, needs time or interest of manufacturer to get certification on ISO. We know that in Europe there is the process that the adoption of ISO will not be done with the publication date immediately, but there is a transition time being for, let's say, 6 years plus a few months or a year that has been decided in the European committee group, the TC 79, and the transition time clock starts, yes, and in the time of the 6 years, it will be checked whether all the content of the EN documents are taken over into ISO. And with this transition time, I think that more test labs will be prepared for testing.
Yeah, I completely agree. It is very much a needs-driven. I mean, I just use the example that well, it's not European, as Graham said. The BS 8468 series is a British standard for CBRN, but it covers CBRN, but it doesn't cover RN as a test methodology. Whereas Simon is the convener of Working Group 7, which parts 8 and 9 of the ISO standard are separate out the chem and bio elements with the radiological. So again, that for me is the personal view is is very much a step in the right direction. I am very conscious of time now because it's coming towards the end of a lot of people's days. Just one more question in the box for Simon, and it's from Dan Morton at 3M, and it isn't the N95 as efficient as an N100 at the actual particle size and actual flow rate that one would see in real life?
Thank you. Yes. Actually, I read the question, and I have a slide from another presentation. Actually, and I had this slide in reserve for our presentation anyway. But just to talk about filtration and the different mechanisms of filtration that should show in a minute. There are different ways in which material is removed by the fibers that constitute a particle filter, and this leads to different efficiencies at different particle sizes and at different flow rates. So the overall filtration is not like sieving. It's a rather more complicated process. Bottom right diagram, in what should just show in a minute, shows the effect of the different removal processes, diffusion, interception, inertia, and so on efficiency with particle size. Testing, when it's undertaken for respirators, is at the most penetrating size. That's close to 0.2 to 0.3 microns. Whereas the size where you are dealing with biological materials, because viruses and bacteria don't travel alone, as it were, they are attached to something else, usually a liquid droplet or sometimes a solid dust. You're dealing with particles that are at higher sizes, where the efficiency of just about any particle filtering respirator that achieves an approval is very close to 100%. So the answer to the question is yes. You aren't going to see a lot of difference between an N95 and an N100 in terms of the effective efficiency that you obtain when the respirator is worn for healthcare applications. And so yes, it's a trivial distinction. I think at this stage you can use an N95 as effectively as an N100. That's my opinion. But others may wish to comment on that too. Yeah.
No, that's brilliant, that Simon. Thank you very much. In the interest of time, I am going to call a time in terms of discussions. I'm just going to share my screen. Sorry, did you want to say something, Wolfgang?
No, thank you.
Okay, so that concludes today's presentation. I'm just going to quickly move on to the rest of the year. So apologies for the shameless plug. There is a bit of a holiday break now for the summer holiday for those who are allowed to go on holiday. So the next webinar is on particulate pollution on the 18th of August. So we will be advertising that in the next couple of weeks, and then confined space, the hidden hazard, on the 7th of October. And then the final one for 2021 is radiological hazards, which has been in running collaboration with the Society for Radiological Protection. And that will be a case study event on the 9th of December. So that is the presentations and webinars for the rest of the year. If you want any information, this presentation will go out along with today's speakers. So Mike Williams, the secretary of the local section, will be able to help you. The email's on the screen. If anybody needs any more information, you can find me on LinkedIn or just drop me an email. And with that, the final thing I want to do today is to thank our very international panel of speakers. I thought it was an excellent webinar, and thank you much for all the detailed presentations that you've put together. So with that, I will wish everybody around the world a very good evening, because it's great. I've just been looking at the attendees list, and we've managed to achieve people from every chapter within ISRP, so all 6 sections, which is fantastic to see. And with that, I will bid you a fantastic rest of your day or evening. So thank you very much.
Thank you. Thanks so much. Yeah.